All right, let's look at a more challenging question. Let's take a look at this one. Now, this is kind of interesting. First thing you have to do is always write down what is the basis of your equations. Your basic equation is y equals to 2 to the power of x. All right, ignore all those other things that are on there. Ignore the negative, ignore the 0.5, ignore this 3/2. We'll worry about that later. So let's take a look at this basic equation and let's see what that's going to make us. I just happen to have it already in our calculator right here. So our basic equation is going to look like this. So you can see that I've got the y to the power of x. I've got the graph for it here. I even have the most important part is a table of values. So why don't we write out all of these table of values right now, okay? So I'm going to start a table of values right over here, and that's going to look something like this. Here's my original x, y table of values. And if you look at this graph here, and I'm going to cycle back and forth between the calculator and the graph, and let's see what it is. There's 0, 1, 1, 2, 2, 4. Okay, so 0, 1, 1, 2, 2, 4. Okay, let's put a couple more points down there just to make sure it's really, really nice. 3, 8, and 4, 16. I think that'll be enough. 3, 8, and 4, 16. We can always return back to it if we feel we don't have enough points. Now, what we have to figure out here now is how is this graph transformed? Okay, and you remember that nice little formula which said x over the b, right? Okay, plus the h, right, gives you ay plus k, and that's what we used way back in the other transformations. And I know they've changed these letters for us, but you know they virtually mean the exact same thing anyways, because if you look here, we have to look, and I'm going to deal with the y term first. I'm going to deal with this term first. If you look at that. There's the value right there. You know that value is a -1, so put it in there. Notice that there's no plus something out here or plus something out here, so in fact the k is a 0. So you actually will be taking every y and you're going to change it to its opposite, its additive inverse. And if you think about that, and if you go back to what we taught and way back in Math 20-1, you know and I know that if you've got a negative up front right here, that means a flip over the x-axis. So you're going to get a reflection over the x-axis. So instead of remembering from Math 20, instead of the happy parabola, now you got the sad parabola. Well, in this particular case, you know and I know that this guy is going to do this, right? So you know that your new graph is probably going to do something that looks like that, because that's what a flip over the axis is going to look like. Well, I'm going to erase this because I don't know what our new graph is going to look like, and I'm going to go back to this equation and start playing around with it some more. So far, we have minus y is going to be our new equation. So comma minus y. That's going to take every y and put it in there and just make them all a negative. Well, that'll be really easy to play with. The crunch comes in right here in this equation. And this is where I get a majority of the students. And I'm just going to clean this up a little bit. And oops, let's get rid of this part because I want to show you something that's really, really important. What I want to show you is this. This is where I get you. 0.5x plus 3 over 2. And people will look at that and say, oh, well, then the horizontal is 0.5. Yes, but how much is this going to move? And people will say, oh, it moves 3 over 2. No, it doesn't. One of the reasons why is because of this. You remember, you have to have nothing in front of the bracketed x. So what does that mean? You have to factor out a 0.5 out of this and a 0.5 out of this. And when you do, look what happens. You get a 0.5 x plus something. So in other words, it is a 1 right here in front of that x. And that's what you have to have in order to get the proper values of the transformation. So you could just close off the bracket there. So factor out a 0.5. So in fact, all you're doing is factoring out a half. So divide everything by a half. All right, so that means a half divided out here gives you just the plain old x, and a half divided out here, well, let's figure out what that works out to be. 3 over 2 divided by a half is the same as saying times it by 2 over 1. The 2's cancel, leaving you with, look at that, you have a movement here of 3 units to the, that's right, to the left. It's moving left. So what are your values here then? Well, you know what? Here's your values. Here's how you're going to do this. You're going to go x. Let me clear off some room here for us again. You're going to have x over b. So you know and I know that the b now is going to be 0.5, 0.5, plus this value here. Well, wait a second. That value, if it's a plus, means it's going in the left direction. So you're actually subtracting a 3. So how do you make this into something pretty? Well, you know and I know if you're going to divide by 0.5, it's the same as saying dividing by a half, which is the same as saying timesing it by 2. So in fact, you're actually doubling all of the x values, okay? And you're subtracting 3 from it. So there's your new equation. Boy, that was a long-winded explanation of how to get there, but you know what? It's going to work really, really nice for us. Okay, so let's start taking every one of these values, and let's go. 2 times 0. 2 times this 0 minus 3 is, in fact, minus 3. Okay, let's do this guy. All you're going to do is take the negative of it. So it's the new point. It's going to be minus 3, minus 1. Watch again. 2 times 1, right, is going to give you 2. Minus 3 is minus 1. And this, you just flip the sign, minus 2. Why? Because that minus y tells you to flip the sign. Okay, here we go. 2 times 2 is 4. Minus 3 is 1. And flip the sign of that guy. Wow, this is actually turning out to be quite easy. 3 times 2 is 6. Minus 3 is 3. Flip the sign, minus 8. Okay, 4 times 2 is 8. Minus 3 is 5. And flip the sign is minus 16. So now all we have to do is go out and graph this whole new line. So here we go. Minus 3 minus 1. So minus 3, 1, 2, 3, minus 1 is here. Okay, minus 1, minus 2, there's minus 1, 1, 2, there's minus 2. Okay, 1, 4, 1, 2, 3, 4, it looks like it's here. 3, 8, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And then 16 is going to be somewhere way the heck down there. And look what you're getting. In fact, you are getting that reflection on the x-axis that we predicted. And of course, you're compressing or expanding the graph and shifting it left to right. This actually works out to be quite easy as long as you remember that you can always use that beautiful formula right here that you derive from the original equation there. Okay? Okay.